Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VNR VJEC. I welcome you all to the lecture series on highway geometric design. Today as a part of lecture series, we are going to discuss the horizontal curves. So if you look into the definition of the horizontal curve, or what is the necessity of the horizontal curve is nothing but if you want to change the direction of your travel. So for example, you are traveling along this path which is given as AB in this figure. So there is a path which is given over here. So that is a straight path and you want to change your direction towards right side. So you want to shift your direction of travel towards BC. So this is in this direction. So that is why you need to have the horizontal curve. Okay. So if you look into this portion up to this location is a straight road. Okay. You all know that the radius of curvature for a straight portion is nothing but radius is equal to infinity, which means nothing but curvature is equal to 0. Okay, and again in this straight portion also you are having the same conditions, but somewhere in the middle between the two straight paths you have to introduce a curve such that the radius should be reduced from infinity to a constant value c. So that is what you want to introduce a curve. That is what is mean by introducing a curve. So bringing the radius from infinity to a particular value, constant value, that is nothing but c, is said to be the intersection of the horizontal curve. This horizontal curve you have to visualize that you are seeing in the plan. That is nothing but you are seeing the top view of any particular road. So that is how you will end up the horizontal curve. So this particular angle, which is nothing but this is my original path which is over here, and this is my changed path over here. So the angle between both of them is said to be the deflection angle or the deviation angle. So if you want to calculate what is the curvature for a road for 1 kilometer, so it might be any number of curves like this. So it might be having horizontal curve like this. So you have to calculate the deviation angle over here. So this is d1. Okay, and you have to calculate the deviation angle over here. Okay, this is d2. Okay, like that you have to calculate you have to find out the deviation angles over the length of 1 kilometer and you have to add all of them. So that is said to be your complete radius of curvature for 1 kilometer length. So this is the basic introduction regarding the horizontal curve. It is nothing but when you want to change your direction of the travel, you are going to introduce your horizontal curve. That means nothing but that straight path which is having a radius of infinity will be brought to a constant value c in order to introduce a curve. So this is what the same diagram which I have explained in the previous slide. So this is nothing but the path 1 at the zone 1. So I am dividing this particular figure into 3 zones. This is the zone 1 which is nothing but a straight path, and there is another zone here over here, that is nothing but zone 2, and there is another zone here over which is in blue color, that is nothing but zone 3. Here, as I have discussed in the previous slide, here you are getting a radius of infinity, or you are having a radius of infinity, and you are getting you are ending up with a radius of constant value c. Okay, whatever it might be, you want to arrive at a radius value constant value in the zone 3. So this is zone 3. Okay, so that you cannot do at a stitch, or you cannot abruptly bring your radius from infinity to a constant value. That should be done or introduced gradually by having a kind of curve which is said to be the transition curve. So this portion or the zone 2 which is we are having here, so that is said to be a transition curve. It means nothing but it will not bring the radius suddenly to a constant value. It will bring gradually from radius from infinity to a constant value. So that means nothing but the type of the curve what we prefer generally for transition curve is nothing but like spiral. Okay, so this is nothing but, so if you take the center of this curve, you are going to have radius over here as something, and here something other value, some other value over here, some other value here. So you are going to have different radius. So such a kind of curve is said to be the transition curve. A curve in which the point from point to point you are going to have the change of radius. Such a kind of curve is said to be the transition curve. So here you are going to introduce any kind of transition curve. And here this is nothing but the zone 3, which is nothing but a horizontal curve. This is nothing but arc of a circle. The arc of a circle is nothing but there is arc of a circle like this. Okay, so this is a circle and you cut some portion of the circle. So this is nothing but your arc of a circle. This arc of a circle is going to have a constant radius. That portion is present in the zone 3. So this is regarding the different zones what we come across in the while providing the transition curve. Okay, and if you look into these 3 figures over here, so that is regarding to again different zones over here. So this is zone 1 and this is zone 2 and this is zone 3. Zone 1 is nothing but the straight portion, zone 2 is nothing but the transition portion, and zone 3 is a circular portion. Okay, so in this what is going to happen on the vehicle? Okay, here when you look over here, when a vehicle traverses a horizontal curve, there is some amount of centrifugal force which is acting horizontally outwards through the point of center of gravity. So that is what it has been mentioned. The moment you enter into the zone 2, okay, so when you are taking in this portion, particularly I'm taking like this and I'm traveling like this, so I'm moving towards this direction, so which means nothing but this side will be the outer edge and this side will be my inner edge. Okay, so there will be some amount of centrifugal force acting on the outer edge. The similar way, when you are moving in this direction, so this is my outer edge and this is my inner edge, so there is some amount of centrifugal force which is acting on the outer edge. So this is what here P, it is represented in all the three figures, which is nothing but the centrifugal force which is acting in three different figures. Okay, so here the only difference is when the vehicle is at zone 1 or when the vehicle is in the straight path, so you can see RA and RB, which is nothing but the reaction which at the location A and reaction at B. So if you look at the pressure distribution at RA and at RB in the zone 1 particularly, so this is my RA and this is my RB. Okay, if you look over here, so this is nothing but approximately RA is equal to RB in this condition. It means nothing but the pressure distribution will be equal in terms of the horizontal path or the horizontal zone. Sorry, that is nothing but in the straight portion you are going to have RA is equal to RB. So this is the condition where you are going to have RA is equal to RB, which means nothing but the pressure bulbs will be equal under both the tires. Now if you come to this second figure, so this is nothing but second figure or figure regarding to the zone 2 under transition curve, and this is a figure regarding to the straight portion, and this is a figure regarding to the third portion, which is nothing but the central portion of the circular curve. If I come to the zone 2, so this is my zone 2, so this is again RA and this is RB. If you can see, there is a difference, there is a shift of the pressure, okay, from RA to RB. So some amount of pressure has been shifted from RA to RB. So which means nothing but there is some amount of centrifugal force. Here there is no discussion regarding to centrifugal force, because as and when we are having RA is equal to RB, so there is no centrifugal force present in the vehicle. But in this case, RB is greater than RA or RA is less than RB, which means nothing but you have entered into the curve portion. Okay, so that is why there is a shift of pressure from inner bulb or inner tire to outer tire. Okay, or inner wheel to outer wheel. And when you enter into this third portion, that is nothing but the circular portion, okay, you are going to have completely shift. Approximately there will be RA is equal to 0 and there will be complete pressure will be shifted to RB. So this is my RB. So this is the regarding figure zone 3. So where over here RA is very less than RB, which is always almost taken as RA is equal to 0. So in this condition, you can imagine that, so you have entered to the central portion of the circular curve. I am telling this when we don't provide any remedy for centrifugal force. We didn't introduce any superelevation or nothing has been discussed so far. So that is a portion when the vehicle has been entered into the horizontal curve and we don't know, we are looking at what are the different aspects that are going to happen. So when you enter this central portion of the circular curve, so the inner wheel, which is nothing but over here, so somewhere over here, the inner wheel is going to lose the contact with the road. So that is why the entire pressure will be shifted to the outside wheel. So that is why you are going to have the entire weight of the vehicle is being shifted to the position B, that is nothing but the outer edge. So these are the different conditions at the different zones. So here it is RA is less than RB, and here it is RA is approximately equivalent to 0, okay, and RB is completely weight of the vehicle. So always you need to remember some points over here. So irrespective of the orientation of your vehicle, okay, always your centrifugal force will be horizontal, okay, and that will be acting vertical horizontally, and it will be acting outwards. Always it will be acting in the outward direction. And coming to the weight of the vehicle, irrespective of the again orientation of the vehicle, the weight of the vehicle is going to act vertically downwards. That is going to act downwards and in the vertical direction, and the centrifugal force is going to act in the horizontal direction through the point of center of gravity outwards. So these are the regarding the different pressure distributions at different zones of the road. So this is again the same vehicle which is being present over here. So there is some centrifugal force acting over here, P, which is nothing but again outwards. So this is my outer edge and this is my inner edge. So this is somewhere in the portion of the central curve. Okay, so there is centrifugal force acting on the outer edge, and this is my inner edge. Now we'll look into the derivation of this centrifugal force. Okay, generally the centrifugal force is given by the equation P is equal to mv square by r. Okay, and if you represent that m as w by g, so P is equal to w by g into v square by r. So therefore, I want to get some parameter which is nothing but, if I am bringing this w over here, this will be P by w is equal to v square by gr. V square by gr. So this is nothing but equation 1. So that's the same thing over here. This is nothing but equation 1. So initially we have the centrifugal force which is acting in the outward direction on the outer edge. So which is given by the equation P is equal to mv square by r. So I have arrived at parameter P by w, which is nothing but v square by gr. That this P by w over here is very important. So there is a different naming for this. So that is nothing but centrifugal ratio. This is said to be centrifugal ratio. It is also called as jerk factor, or this is also called as impact factor. So there are different names for this P by W, which is nothing but the centrifugal ratio, or jerk factor, or impact factor. If this is P by W is called as impact factor or jerk factor, the value which is going to be equal to V square by GR, this is also can be called as impact factor or jerk factor. So this is regarding the equation 1. Okay. Now the centrifugal force which is acting on the horizontal curve, I mean on a vehicle in the horizontal curve portion, will have two effects. One is nothing but it is going to have, okay, so the centrifugal force acting on a vehicle negotiating the horizontal curve, it is going to have two effects. One is nothing but the tendency to overturn the vehicle outwards about the outer wheel. So that is what the centrifugal force which is present over here is going to have two effects. One is nothing but it is going to overturn the vehicle outside the road, and it is also having the tendency to skid the vehicle laterally outwards. So either ways, it is either going to skid the vehicle in the outward direction, or it might be chances that the vehicle may overturn in the outward direction. So that is the effect of centrifugal force. Now we have to take some remedy measures in order to counteract this both the effects. So that is what we will be discussing in the subsequent slides. And before that, we'll see what are the different I mean forces again acting on this, and we'll go with small derivations over here. So this is the inside curve of the curve, and this is the outside of the curve. Again the same centrifugal force which is acting over here, and this is the weight of the vehicle present over here. Now I told you that in the zone 3, when you enter the central portion of the circular curve, your vehicle the vehicle is going to lose contact at the point A, and the entire pressure will be present at the position B. So this is my only point of contact in the central portion of the circular curve. Now I am going to write the momentum equation at B. So that is nothing but momentum, algebraic moment at the point B is equal to 0. So then you look into the forces which are acting over here. So one is nothing but the centrifugal force which is acting horizontally outwards. So this is nothing but P, and the distance at which it is acting is nothing but height of center of gravity of the vehicle, P into H, minus, so this is acting in the clockwise direction. The other force which is acting over here is nothing but the weight of the vehicle, which is nothing but W, and it is acting at a distance of B by W. B by 2, this is equivalent to 0. So that if you simplify this, PH is equal to BW by 2, and this again I want to get the parameter which is nothing but P by W over here. So P by W is equal to B by 2H. So this is what the second equation what I am getting over here. So this term which is nothing but B by 2H, I am going to write over here. B by 2H, this parameter is said to be the resistance to overturning. Very important, resistance to overturning, OT. I am writing it as in abbreviation, that is nothing but resistance to overturning. So this is already we know this P by W is nothing but centrifugal ratio or jerk factor or impact factor, and this B by 2H is nothing but resistance to overturning. It means nothing but higher this value, it means nothing but higher resistance to overturning. It chances are that the vehicle may not undergo overturning if this value is higher, because the name itself is nothing but resistance to overturning. So because in the previous slide we have discussed that the tendency of the vehicle to overturn outwards about the outer wheel. So that is why we have checked the resistance to overturning. And similarly we have looked into the point 2, which is nothing but it has the ability, the centrifugal force has the ability to skid the vehicle laterally outwards. So we have to look into that derivation which is involving the lateral friction also, sliding. So therefore here the same diagram over here, some portion where the pressure distribution are unequal, some portion was taken over here. Now we want to take the forces acting over here. So I'll take sigma fx is equal to 0. The forces acting in the horizontal direction is equal to 0. So here the horizontal force which is acting over here is nothing but only P. Okay, and I'm having that is acting in the rightward direction, so in this direction, so I'm taking this as positive. And here the only forces which are acting in the opposite direction is nothing but, as a vehicle is trying to move outwards, the centrifugal force is going to act in the inward direction, and this is the FA, that is nothing but frictional force at location A and frictional force at location B. So therefore this will be in the opposite direction, so that is nothing but minus and FA plus FB. Okay, so this is equivalent to 0. So therefore P is equal to, I'll take FA plus FB on the other side, FA plus FB, and P is equal to, FA is nothing but frictional force, which is nothing but the coefficient of friction. Here in this case it is nothing but lateral coefficient of friction, FL into coefficient of friction multiplied by normal reaction. So therefore it is nothing but RA plus FL into RB. So therefore P is equal to FL, if you take common, RA plus RB, which is nothing but the weight of the vehicle. So this is P over here. So now we are again getting the another equation, which is nothing but P by W is equal to FL. So this is the equation 3. So we have total 3 equations, which is nothing but, first equation is nothing but the centrifugal ratio P by W is equal to V square by GR, and that is also equivalent to P by W is equivalent to B by 2H regarding to the resistance to overturning case in terms of overturning. And we also have the third equation, in which we have P by W is equal to FL. This parameter over here is nothing but resistance to sliding. Very, very important. This terminology is very, very important. So first one is nothing but P by W, which is nothing but the centrifugal ratio, and B by 2H is nothing but resistance to overturning, ROT, and this is nothing but resistance to sliding. Okay, higher the value of resistance to sliding, it means nothing but the vehicle, the chances are sliding is very, very less. So this is regarding the stability conditions of the vehicle, or based on the different forces acting on the vehicle, we are going to establish what are the different stability conditions of the vehicle. So if you look over here, so previously we have got the equations, which is nothing but P by W is equal to V square by GR is equal to B by 2H is equal to FL. So now I am eliminating this portion as I am not interested over here. Maybe you can get this value if the value of P by W is not given. So they will be giving the speed and they will be giving the radius of the horizontal curve. So based on which you can calculate the value of P by W. That is only the use of V square by GR over here. And we have B by 2H and we have FL over here. So now we want to say what are the different stability conditions of the vehicle. So this is case A, and this is case B, and this is case C, and this is different case D. Here in this equation, if we can see, P by W is less than B by 2H. Already we know that B by 2H is nothing but resistance to overturning. Here it has been mentioned that resistance to overturning is higher. So this B by 2H is higher when compared to that of centrifugal ratio. So that is why when resistance to overturning is more, so therefore no overturning is going to happen here. So that is what the stability condition of the vehicle. So no overturning is happening over here. But if you look over here, again P by W is less than FL. Here F stands for lateral coefficient of friction, because the friction is acting in the lateral direction. So we have discussed that F, which is nothing but longitudinal coefficient of friction in stopping side distance. Kindly make a difference between longitudinal coefficient of friction small f and lateral coefficient of friction FL. Here also it has been mentioned that P by W, again centrifugal ratio, is less than FL, which means nothing but FL is higher when compared to that of centrifugal ratio, which means nothing but again resistance to sliding. This term what we have mentioned is nothing but in the previous slide, so that is nothing but resistance to sliding. Here also, as we are having higher resistance to sliding, so therefore the vehicle is not undergoing the sliding phenomenon. So this is very, very important, the case A, where you don't have the chance of overturning the vehicle, or either you don't have the chance of sliding the vehicle. Now if you look into the case B, in which it has been mentioned that P by W is higher when compared to that of B by 2H. So resistance to overturning is less. So when you have resistance to overturning less value, so therefore the chances of occurring the OT is possible, therefore overturning occurs. And this remains constant, P by W is less than FL, which means nothing but resistance to sliding is higher, so therefore you don't have the sliding condition. So this is the case B. In the first case, you don't have either chance for overturning and you don't have chance for either sliding also. And in the second case, as B by 2H, which is nothing but the resistance to overturning is less, so therefore your vehicle have the chances of overturning. And as your resistance to sliding is higher, so the vehicle will not undergo sliding. So if you look into the third case C, which is nothing but P by W is less than B by 2H, here resistance to overturning is higher, so it means nothing but no overturning of your vehicle. But whereas if you look over here, P by W is greater than FL, which means nothing but FL is less than P by 2H, resistance to sliding is lesser, so therefore sliding is going to happen over here. Okay, so that is regarding the case C. And you will look into the case 4 or the D case, which is nothing but P by W is greater than B by 2H, that is nothing but resistance to overturning is less when compared to that of centrifugal ratio. And again P by W is greater than FL, which means nothing but again resistance to sliding is also lower. So here in this case overturning occurs and again sliding also occurs. So these are the different stability conditions of the vehicle. Based on the given values, you need to, sometimes they might be given directly the centrifugal ratio value P by W, or else they might be giving the speed of the vehicle along with the radius of the horizontal curve, by which you can calculate the value of P by W, which means nothing but the centrifugal ratio. And apart from that, you are also given the height of the center of gravity of the vehicle along with the width of the vehicle. Based on that, you need to calculate the different values like B by 2H, P by W and FL. The lateral coefficient of friction may be given directly. So adopting these values, you have to do this calculation under which case it is coming, and you have to discuss the stability conditions of the vehicle. If you look into this fourth case, both overturning and sliding are happening, both are happening. So now we have to understand which one occurs first. So that is what the next cases will be. So this is in the D case where we have P by W is greater than B by 2H and P by W is greater than FL. So in which we have both overturning and sliding. So we have to see which one is going to occur first. So as P by W is greater than B by 2H and P by W is greater than FL. So we have to check comparison between B by 2H and FL, which means nothing but which is going to occur first. So in this case, B by 2H, which is nothing but resistance to overturning, is lesser when compared to that of resistance to sliding. So resistance to sliding is higher, so therefore here overturning resistance is less, so therefore overturning occurs first. Both are occurring anyhow, so overturning occurs first followed by sliding. Why both are occurring means because both the values are less than that of P by W. So both are occurring. So but the first one is nothing but overturning occurs first. So this is the first case in the D sub case, and this is the second case in the D case where we have B by 2H is greater than FL. So B by 2H is nothing but resistance to overturning. So I am writing it as resistance to overturning is higher when compared to that of FL. So here as resistance to overturning is higher, so therefore sliding occurs first. Sliding occurs first, followed by overturning. And the third case in which where B by 2H is equal to FL. So lateral coefficient of friction FL is equivalent to B by 2H. So both are occurring and both of them occurs to be equal at the same point of time, but here overturning dominates. Overturning dominates and followed by immediately sliding. Followed by sliding. So there is a small problem over here. So given over here, the value of the centrifugal ratio, which means in our condition, it is nothing but P by W is equal to, it is already given. So sometimes you have to calculate the value of P by W. So it is given as 1.5, and the width of the vehicle, which is nothing but the W or B in this condition, is nothing but 2.4 meters. And the height of center of gravity of the vehicle, which is nothing but small h, is equal to 1.2 meters. These are the data which has been given over here. And FL is equal to lateral coefficient of friction, which is given as 0.15. Okay, now we have to check the stability conditions of the vehicle. So this is P by W and already directly given. Now we have to check the resistance to overturning. So resistance to overturning. So we know the formula for resistance to overturning is nothing but B by 2H. B is nothing but over here 2.4 divided by 2 into H, 2 into 1.2, that is nothing but again 2.4, which is nothing but 1. So therefore resistance to overturning is nothing but 1. So now we will look into the resistance to sliding. So resistance to sliding is nothing but FL, which is nothing but over here 0.15. Now we have to compare between P by W and B by 2H. So B by W is 1.5 over here. So this is 1.5, the value is 1.5 over here. and b by 2h is nothing but 1. So p by w is greater than b by 2h, and the second condition is p by w again 1.5, which is greater than fl, which is nothing but fl is nothing but 0.15. So therefore 0.15. So this is p by 2h is greater than when compared to the resistance to sliding, and p by 2h centrifugal ratio is again higher when compared to that resistance to water turning. So the condition is nothing but both are going to happen. So both occurs. When you know that when both are happening, then again you have to compare between b by 2h and fl. b by 2h is 1, which is greater than of 0.15. So the resistance to water turning is higher. So therefore sliding occurs first. Sliding occurs first. So this is a very important problem in terms of the competitive examination also. So just small formulas, if you insert that, and you have to analyze what is the condition that is going to happen, comparison different parameters. So I sincerely acknowledge the use of publicly images, available images, and that supported and enhanced the visual clarity of this presentation. Thank you. I conclude the session over here.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.